Okay, so now that we know the difference between a scalar and a vector, we need to learn how to manipulate them. Okay, so and what we typically end up doing in physics is we need to combine them in some way to determine what the combination of them means in motion. So, scalars are fairly simple, just like they are a simple just number and a unit. Their addition is very simple as well. You literally just add the numbers. Okay, so if you have 5 meters and 5 meters, to get this as a correct answer, you would want to say that you have 10 meters. Alright, the big thing you want to watch out for is make sure you have the same units. And this applies for all addition of quantities. It's supposed to be 1t. Same units. Alright, so let's get vectors. Vectors are a little more complicated, but there are 2 simple rules to follow, and if you always follow those rules, adding vectors shouldn't be very difficult. So, if you want to combine 2 vectors, you have to set them up so that they are touching head to tail. So, what that means is you have the head of this vector touching the tail of the other vector. Alright? Now, what you actually are trying to find is the addition of those 2 vectors, which this part's the addition, your resultant. And the resultant always goes from the tail of the first vector, or you could call that the open tail, to the head of the last vector, or you could call that the open head. Alright? And the direction of your resultant, okay, adding vectors, you end up with a vector, it has to have a direction, is always from that open tail to the open head. Alright? Now, I drew or included this picture because it was a little just easier to see what was going on, and the resultant is clearly a little different, but for right now, this would be called 2 dimensions, and we'll get into this in more detail with chapter 3, but right now we're going to focus on things in 1 dimension. So let's show a couple examples of adding vectors in 1 dimension. So 1 dimension means that they are either pointing in the same direction or pointing in exact opposite directions. So let's say we have these 2 vectors. We have sorry, didn't mean to move that. My program is weirding out on me. So we have this vector here, which is, say, 1 meter, alright, and we want to add it to this vector, which, let's say, is 3 meters, alright. Just like with scalars, you do, again, want to make sure that you have the same units before you start adding them, but we're going to follow the same directions as before. We're going to set these vectors up so that they are touching head to tail. So the head of one is touching the tail of the other. Alright. And then our resultant goes from the open tail, which is going to be back here, to the open head. Right? I'm drawing this a little below just so that it's easy to see and it doesn't blend in. But again, if you do something like this, make sure that you are drawing it parallel to your addition, if they're both going in the same direction, right? And if you notice, I mean, this is pretty easy. You have your 1 meters and your 3 meters, and since they're going in the same direction, all you end up doing is your resultant is those combined, which would be 4 meters. Alright, and you could call this 4 meters east, because east is to the right, or since it's to the right, you could also just say it's plus 4 meters. Okay? So, let's see what happens when you have things going in, say, opposite directions. So let's make this a little longer. Let's do 3 meters up, and then we have a 2 meter vector down. Okay? So again, same rules apply. You have to set them up so that they're touching head to tail. So let's draw our 3 meter guy again. And starting at the head of this, we will put the tail of our downward vector. Alright, so there's our 2 meters. Okay, so this is still touching head to tail. Your resultant will still go from your open tail to your open head. So, right there. There is your resultant vector, alright? And especially since they're going in opposite directions, you know one is going up, one is going down. You can apply some numbers here. Down is a negative direction, so 3 plus negative 2 leaves you with, you can also think is where they are touching, alright, they are overlapping. So you are left with 1 meter up, which you could call north, or you could just say again plus 1 meter. Alright, so let's give you a chance to practice. You try these. Alright, so pause the video on, a piece on your notes or something like that. Just draw some things to indicate these. Alright, and I will, on the next slide, I will be solving them for you. Okay, so add the scalars 10 meters and 15 meters. Same units, so you can add those. Pretty easy. 10 plus 15 equals 25 meters. Hopefully that was easy as it was for me, for you. Show a vector that's 1 hand length. This is just, take the length of your hand. Alright, so if this is your hand, your vector would look something like this. The length of your hand and pointing east. Not meant to be too difficult. And part, hopefully not difficult, but possibly the most difficult. You have 2 vectors. One is a positive 3 meters, so you could draw it like this. Alright. Then the other one is a negative 4 meters, which you could draw like this. But because it doesn't tell you left, right, up, or down, you could have also drawn them like this. Okay? Now, to set them up head to tail, they have to be kind of overlapping. Do that a little long. So they look like this. Alright, and your resultant is going to go open tail to open head, point this way, and the part where they overlap, they cancel out. And you can also treat it like positive 3 minus 4, which leaves you with negative 1 meters or 1 meter west. Okay? So, especially if the problem is given to you in pluses and minuses, don't bring in the cardinal coordinates. Stick with negative 1 meters, because if you had set them up, say this way, you can still get negative 1 meters, because your resultant is going to be pointing down, but you can't get west. Alright? So if it's given to you in positives and negatives, stick with directions being in positives and negatives. Alright, so that's the end. There is one last little short thing to add in a third video. Alright?